All right, good morning. I'm going to go ahead and talk about how I would teach this proof to my students. It's been quite some time since I've taught a geometry class. I only taught it my first year of teaching, and it was an informal geometry class, which is just the same thing, same content as geometry. It's just usually not quite as heavy on the proof part of geometry. So, I'm going to talk about where I would start. I guess for me, when I've taught proofs in the past, I always emphasize, like many of you probably do, just talking about what do we know. And I know when I taught informal geometry, we used a lot of colors when we were doing proofs. I often had colored pencils or highlighters and things out. Students tended to do a little bit better when they had those colors just to see things that are similar and such. So if I was teaching this lesson, I would obviously be doing this on my smartboard. We were lucky enough to have a snow day today, so I don't have access to my smartboard, so I'm just going to do it on my iPad here. I always give students printed out version of the notes so that they don't have to worry about copying down this picture, copying down all this information. I think it makes things just go faster, number one. And number two, as most of you know, students just are not reliable to be able to copy down things exactly how they see them. So if I can give them this note or the copy of this example ahead of time, it's just going to make things go a lot smoother. So again, when I'm doing this, I first have the students look at the given part and we just see what they tell us. They tell us first off that segment YZ is congruent to YV. So this is where we'd get out a color, right? YZ, and I'd color that, and YV, I'd color that one too. We talk about the tick marks, and we still use those as well, but I think using the color on top of that until we're completely comfortable with just the tick marks, I think that's an important first step, especially when students are newish to doing proofs. So then we have a second given. We have XY is congruent to segment WY. So again, I might highlight that. I should have probably done that for the beginning, but I'm going to go ahead and highlight those sections as well. All right, so once we know that, we're going to go ahead and start our two-column proof. This would not be the first time students have done a two-column proof, so we would start just by setting up our T-chart here. I like to ask students, what do we put in the first column? They should be well versed in two-column proofs by this point, so we know we'd put statements here. And then we always put reasons on the right-hand side. I always tell students, start with the easy one, basically the freebie, what they give you. Everyone should get the first point in a two-column proof. And we're going to go ahead and just write down what they tell us, the given. So we have YZ is congruent to YV, and XY is congruent to WY. Again, that's just our given. After this point, right, I just have the students, a lot of times I say, hey, let's just all be quiet for about 10-15 seconds. Just look at what we have here, and let's try to figure out some other things that we know, or what do we notice here. Again, I like to give every student a chance just to look at it in silence for a little bit, because there's always going to be students that see things a lot faster than others. And I just want to give everyone a chance just to try to think through it by themselves. And then I'll probably open it up to the class and say, well, what do we notice? Usually, or I'd hope that there'd be a couple students that would say that, oh, it looks like we have two isosceles triangles, right? And we know that because we have two triangles that have two congruent sides. I know that not every student might see that right away, but I think that's okay, because the more times we do proofs like this together, the more often they're going to see some of these things, like, oh shoot, I wish I would have saw that, or I can't believe I didn't see that. And then maybe the next time that, again, they see isosceles triangles, they'll think back to this example. A lot of things with proofs tend to kind of repeat themselves, or you see them again. So I do feel even if you don't see it the first time, hopefully the second or the third time you'll start to recognize that, hey, these are isosceles triangles. So we would go ahead and we would write that down as our next line here. So we know that we have isosceles triangles, so we're going to go ahead and write that down. So we have triangle XYW and triangle BYW. Oops, sorry, BYZ. Oops, wrote the wrong letter there. BYZ are isosceles. And again, we know this because of the isosceles triangle theorem. We would probably at this point just take a second to talk about what the isosceles triangle theorem is again. And we just come up with that, hopefully someone could provide me with that, if we have two sides of a triangle that are congruent, then we know that their two base angles are also congruent. So since we know that they're isosceles, this is where we'd go back and we do some marking. I'm just going to keep marking with my pen here. But again, this might be something where we'd grab another color and do some more markings. But again, we know those base angles are congruent, so I'm going to go ahead and mark these two angles as congruent. And these two angles over here as congruent. And we'd want to make sure that we go ahead and write those down. I love to have students give me the angles just so they get practice with naming. I know at first when we start talking just about corresponding angles and corresponding sides, students often struggle just with the naming part or the locating part. So I always like to go to them for this section. But hopefully that someone would give me something like angle XWY is congruent to angle WXY. There's two of our base angles, and then somebody else would hopefully give me that XYW is congruent to angle YVZ. And again, the reason here we just know this, it's because again that isosceles triangle theorem. So at this point, hopefully we know we're getting close. I think in a previous video, and I was thinking the same thing, a lot of times I say, well, now what do we notice? A lot of students like to point out the vertical angles. But then this is where a great time where we think about, well, how do we prove that two triangles are similar? And someone's going to say, well, we would use that angle-angle similarity theorem. And I'd say, well, yeah, that's perfect. So technically, do we need to know that those vertical angles are congruent? Not really here, right? And we could put that down because that is a true statement, but that's not really necessary for a proof. We often talk about, in my class at least, that mathematicians, I always joke, are lazy. We like to do things in the shortest amount of steps possible with the least amount of writing. So we do not need to put down that vertical angles idea. We can go ahead and just do our conclusion here. Since we know about those angles being congruent, we can go ahead and say that triangle XYW is similar to triangle VYZ. And my line's got to keep coming down. And again, we know this because the angle-angle similarity theorem. Obviously, before this example, we would have spent a lot of time just talking about what the angle-angle similarity theorem is, how to look out for it, and all those sorts of things. So again, I guess my big takeaways when I'm teaching a proof, a two-column proof, in this case a similarity one, I just like to use colors. We emphasize a lot of what do we know, and just letting students know that it's okay if you don't recognize things right away. Hopefully the next time you see a proof similar to this one, maybe you will recognize some of those key ideas the next time.